Bonsuelo, everybody. Back to polynomial graphs. Last time I just gave you a little bit of a clarification on degree because I didn't want to mislead you. But now we're going to go back to graphs. And what I said last time applies to graphs also. But I'm mainly warning you against that problem in Alex where it's x cubed equals 8, and they do it by taking the cube root. Okay, so a couple things. Zeros versus x-intercepts. Again, same thing I talked about last time. Multiplicity of x-intercepts. What does that mean, multiplicity? Okay. And also looking at the equation to find intercepts and degree, and then determining the number of sections on a graph. So these are clarifications. I've kind of talked about all these things already. It's just, again, I don't want to mislead you. Okay. So real quickly here, zeros versus x-intercepts. So find all intercepts. You should know that the y-intercept here is 0, -7. And on problem 2, it's 0, 7. Okay, for the zeros, I'll set it equal to, I'll put 0 in for y in factor. And same thing here. I'll put 0 in for y in factor. And again, here you need imaginary numbers. Okay, so our zeros are going to be square root of 7 and negative square root of 7. And our x-intercepts here, our zeros here are going to be negative square root of 7i and square root of 7i. Those are values for x that make y 0. What are your x-intercepts? Well, here it'd be square root of 7, 0 and negative square root of 7, 0. Okay, but here there are no x-intercepts. Why? Because imaginary numbers don't plot on an x, y-axis system. Okay, I talked about that a lot the last video, so I'm not going to delve into that anymore. Okay, multiplicity. Find all zeros and x-intercepts and state any multiplicity. Okay, what's multiplicity? It's probably easier if I just show you. All right, so here I'm going to find zeros. So this would be x plus 3 and x plus 3. Okay, so therefore x equals -3. And you don't need to state -3 twice. But notice it is a 0 twice. So that's multiplicity of 2. It just means it's a 0 twice. Okay? Now, what does that have to do with anything? I'll get to in a little bit. Okay, here, number 2. I've already factored it partially for you. Okay. Oh, by the way, on number 1, I forgot the x-intercept. The x-intercept is going to be -3, 0. Okay. Only one x-intercept. All right. Because you can't be at the same point twice. Okay. Here we have x minus 1 is already given to you, and then this is x minus 1 times x minus 1. So what's the value of x? 1 with a multiplicity of 3, because notice it exists 3 times. Okay, and so what is the x-intercept? 1, 0. Now, how can that be? See, when I told you that the degree tells you the number of answers, that's true. That's correct. But the problem is this, again, I don't want to mislead you. It doesn't mean you're going to have that many different answers. Okay? There are 2 zeros here. It's just, it's the same 0 twice, so you don't need to state such. You don't need to write -3 twice. But that also means there's only one x-intercept. Okay, so multiplicity just tells you the number of times that thing is that number is a 0. Okay, but you're only going to get one intercept out of it. So, like on number 2, the multiplicity was 3. That means that 1 is a 0 3 times. You don't need to write 1 3 times, but it's just going to give you one x-intercept. Okay, let's take a look at this. So we have 0. So the first thing are the zeros, and then the second's the x-intercepts. Okay, so we're finding zeros first. So this would be x minus, sorry, that's not correct. Okay, again, I'm going to go back a little bit more to factoring. What times what gives us x to the fourth? X squared times x squared. What times what gives us plus 49 would be minus 7 and minus 7, and that would give us a negative 14x squared in the middle. Now we can factor that further, though, because the x squared minus 7 will factor into x minus square root of 7 and x plus square root of 7. And the other one will factor into x minus square root of 7 and x plus square root of 7. Okay, so what are the zeros? The zeros are square root of 7 with a multiplicity of 2 and negative square root of 7 with it also has a multiplicity of 2. Okay? Therefore, what are the x-intercepts? So we found 4 zeros. The x-intercepts are going to be square root of 7 comma 0 and negative square root of 7 comma 0. Okay, let's take a look at number 3. 0 equals, what do we got? Oh, this doesn't factor. So what do we do when it doesn't factor? Well, we either use the quadratic formula to complete the square. Most people probably use the quadratic formula, so that's what I'll go for. So x equals negative 3 plus and minus the square root of b squared minus 4 times a times c all over 2 times a, which simplifies into negative 3 plus and minus the square root of 29 all over 2. Therefore, what are the zeros? The zeros are negative 3 plus square root of 29 all over 2. And then the other one is negative 3 minus square root of 29 all over 2. And those are also the x-intercepts. The x-intercepts are negative 3 plus square root of 29 over 2, comma 0, and negative 3 minus square root of 29 over 2, comma 0. And, you can figure out what the decimal equivalent of those are, but, using a calculator or whatever, but those are the x-intercepts. So again, things may not factor. And if it's a quadratic, you just use the quadratic formula or you complete the square. Most people opt for the quadratic formula. Okay, so again, that's kind of the same idea of the difference between zeros and x-intercepts, but also the idea of what's multiplicity. Okay, there's no multiplicity in problem, this is problem 4, sorry. Okay, all right, let's find the intercepts and the degree from an equation. Okay, so each of the following tell the degree, leading coefficient, extremes, in other words, up or down, and then the intercepts. Okay, so let's take the first one. So the leading coefficient is positive, okay, and it's 1, positive 1. The degree is 4. The extremes, well, since it's a positive leading coefficient, the right goes up. Since it's to the 4th power, the left's going to do the same. Okay? And then the intercepts, we're going to, the y-intercept is going to be 0, comma negative 4 if we plug in 0 for x. And the x-intercept, we're going to stick 0 and factor it. So it'd be what? What times what gives us x to the 4th, x squared times x squared. What times what gives us negative 4, and positive 1. And then we can factor each of those. And we'll get x minus 2 times x plus 2, and x minus I and x plus I. So notice there are 4 zeros, but only 2 of them are x-intercepts. So 2 comma 0, well, you know what? I'll write out the zeros first. Okay, the zeros are going to be 2, negative 2, I, and negative I. But as far as x-intercepts goes, it's only 2 comma 0 and negative 2 comma 0, because I does not plot on an xy axis system. Okay, in this case, what's the degree of this thing? Well, what's the leading coefficient? First of all, what you have to do is the leading coefficient will just be all those multiplied together. And if you don't believe me, you can multiply it all out if you want. But if you take all of those, that'll give you the leading term. Because it's obviously, I hope it's obvious, going to be x to the third. So what's the leading coefficient? Well, if you multiply all those together, you get 7x to the third. So the leading coefficient's 7. The degree is 3. The extremes, well, 7x to the third. The right, it's positive, so the right's going to go up, but since it's odd, the left's going to go down. Okay, and what are the intercepts? Well, for the y-intercept, you plug in 0 for each value of x. So you get 0 plus 2 is 2. 7 times 0 plus 5 is 5. And 0 minus 4 is negative 4. And that will give you, what, negative 20, negative 40. So it's 0, comma, negative 40. Remember, that's all you do for y-intercept. You just stick 0 in for x. For the x-intercept, you don't really need to show any work here. It's already all factored. It's set equal to 0, or at least you can think of it as set equal to 0. So you got negative 2 comma 0, and it's already factored for you. Negative 5/7 comma 0, and 4 comma 0. Okay? All right, let's take a look at this one. So again, we want to find those 4 things: leading coefficient, degree, leading coefficient, extremes, and intercepts. Okay, so let's go, first of all, look at the leading coefficient. Okay, this is going to be x cubed, because eventually when we multiply it out, you have to think of this like this. X plus 2, x plus 2, x plus 2, then 7x plus 5. And the last one isn't just 4 minus x, it's negative x plus 4. Okay? So if you multiply x, 7x, and negative x, we'll get 1, 2, 3, 4, 5, negative 7x to the 5th. That would be the leading term. So the leading coefficient's negative 7. The degree is going to be 5. The extremes, well, since it's negative, the right's going to go down, and since it's to the 5th power, the left's going to do the opposite of that, so it's, well, that really looks bad. So the left is going to go up. And now to find the intercepts, well, again, to find the y-intercept, I'm going to stick 0, okay, in for all of the x's. So you get 2 times 2 times 2, or you can just put 2 to the third, times 5, and then times 4. So that's going to be, what, 8 times 20 is 160. So we have 0, comma 160. That would be the y-intercept. Okay? Now for the x-intercept, so this is the y-intercept. For the x-intercept, we just take each of them. So we have negative 2 comma 0. And again, I didn't request it, but just so we understand, this is a multiplicity of 3 because it exists 3 times. We have negative 5/7, comma 0. And if we stick negative x plus 4 equal to 0, we'll get 4, comma 0. And again, you can set each of those, actually write each of those equal to 0 if you want to, but it's not necessary. You can do it just by looking at it if you want. Okay? All right. Now, determining the number of sections on a graph. Again, in general, the number of sections will be the same as the degree, but that's not perfect. Actually, the equation degree tells you the maximum number of sections on a graph. Okay? So, x to the 4th means most likely it's 1, 2, 3, 4. But there may just be 2. Okay? When would that happen? If like you just have f of x equals 3x to the 4th and nothing else following it, you'd actually only end up with 2. But in general, what you need to know is it tells you the maximum number of sections. Okay, for x to the 8th, it's probably going to be 1, 2, 3, 4, 5, 6, 7, 8. But it could have maybe 6, okay? Or it could have 2. So it'll always be that degree or 2 less. So the possible number of sections on the first problem there is either 4 or 2 less than that. Because remember, it always has to go, this problem would always have to go up, right, whether there's 4 or 2. It always has to go up right on the, up on the right and up on the left. So it's got to be 4 or 2. Just subtract 2 each time. And the number of possibilities here. Now, most likely, it's going to be 8. But there could be 6. There could be 4. There can't be 2 because this is not a parabola. Well, no, I guess there could be 2. Again, if it was the simplest case of y equals 5x to the 8th, that would actually just have 2. So, but you're probably not going to have to worry about that. Okay? But those are all the possibilities. So most likely the first one's going to be 4 sections and the second one's going to have 8 sections. But it's possible, not likely, but it's possible that it could be 4 or 2 on the first problem, and then 8, 6, or 4 or 2 on the next one. Okay? Now, if we're looking at the graph and going the other way and telling the degree, the number of sections on the graph tells the minimum degree. So here, on the first problem, there's 1, 2, 3, 4, 5 sections on this graph. So what's possible is that this is x to the 5th power, or x to the 7th. It could be an x to the 7th, or x to the 9th, or, 11th, 13th, et cetera, et cetera. Here there are 4 sections. What's possible? That this is x to the 4th, but it could be 6, but it could be 8, et cetera, et cetera. Okay? Again, these are all kind of like minor things. I'm not saying you don't need to know them, you do. But for the most part, the number of sections is going to be the same as degree. Okay? But you have to understand that, like I always say things in general. It's kind of like this at the very beginning. Your degree is the number of values for x. That's true. But it may be a case of multiplicity 2 or multiplicity 3, something like that. So, I just don't want to say things that mislead you. So I'm kind of trying to, again, this is just a lot of clarifications, really, on things I've said before that I could mislead you if I didn't tell you this stuff. So hopefully that's helpful. Next time what we'll do then is actually take a look at graphing things. And I know this seems like a lot to remember, but really once it comes down to it, it's really pretty simple. If you go back and look at the first thing I ever told you, what does this come down to? It comes down to the extremes, which is what I'm talking about right here, and then intercepts, which is what I'm talking about like up here. And that's why I wanted to tell you about intercepts. Now, I'm not sure if I should say this now or I should say it later, but I'm going to say it now. What does multiplicity do for you when it comes to a graph? Well, it's this. If you have a multiplicity that's an even number, 2, 4, 6, etc. Okay. The graph, and I say like this is -3 is the x-intercept. The graph comes down and just touches it. So when I say it's an x-intercept, whoa, what happened there? When I say it's an x-intercept, I don't mean it crosses, okay? What I mean is it touches the x-axis. So if it's multiplicity 2, multiplicity 4, multiplicity 6, it's going to come down and just touch the graph, okay? Whereas if it's a multiplicity that's an odd number, it will pass through the graph, but only once, okay, at whatever that, for that particular x-intercept. So, and again, we'll talk more about that when we actually look at graphs, but these are just things that I hope to clarify, so once we actually put it all together and start making graphs, I think it won't be as bad as all of this looks. I realize there's a lot of information here, but that's why it's important to know multiplicity. Because if it's a multiplicity 2, multiplicity 4, et cetera, it doesn't actually pass through the x-axis, it just touches it. And I'll talk more about that when we graph. I don't really want to say anything more about that for right now. I think I've said a lot. I think I'll leave it at that for right now. Have a good day, everybody.